The big idea in Unit 8 is all about factoring. So what we're going to do in this lesson today is we're going to talk about what a factor is. We're going to refresh our memory a little bit, what a greatest common factor is, and we're going to start with just how do we factor out the greatest common factor. And then in the remaining sections of Unit 8, we're going to focus on different strategies for factoring after you factor the greatest common factor. But the reason that we're learning this section first is because every single time you're approaching a factoring problem, you should always do what we're going to do in this lesson first. You should always check to see what the greatest common factor is and then to factor that greatest common factor out. So today we're really laying the foundation for the rest of this unit. And factoring is one of those topics that's incredibly important, and it's also not really retaught in your future math classes. Starting with next year in geometry, algebra 2, and all the way up, you're going to be expected to know how to do what we're doing in this lesson today without being retaught. So this may be a video that you need to come back to and listen to again. This might be something that you need to ask more questions about in class. That's totally great. We want to lay that foundation now so that you are prepared for the rest of this class and for your classes to come in the future. So 8.1, factors and greatest common factors. Let's just refresh our memory in case you have forgotten what is a factor, because I have already said that word a lot today and I really want to make sure that we're on the same page. Our essential question today, how do we find the greatest common factor and how do we factor it out? So a factor is something that evenly divides a number. So a whole numbers that are multiplied to find a product are called the factors of that product. A number, this is the big part, a number is divisible by its factors. So anything that evenly divides. So if you look down here, you can see the factors of 12 are listed. 1, 2, 3, 4, 6, and 12. 12 evenly divides by 1, 2, 3, 4, 6, and 12. All of those numbers evenly divide into 12. Similarly, down below, we have the factors of 16. 1, 2, 4, 8, and 16. All of those numbers evenly divide into 16. Or 16 evenly can be divided by any of those numbers. Factors that share 2 or more numbers are called common factors. And then the greatest of all of these is called the greatest common factor. Actually, I want to use a different color there, the greatest common factor. So if you look at this example below, where we have the factors of 12 and 16. They both have a 1. They both are divisible by 2. They both are divisible by 4. So 1, 2, and 4 are all common factors. The greatest of these numbers, the largest, is 4. So 4 is said to be the greatest common factor. All of those are common factors, but 4 is said to be the greatest common factor. The other thing that I want to point out is that there is always going to be a common factor because everything is always at least divisible by 1. So there's always going to be a common factor. That common factor just might be 1, which is a little bit boring, but it is still true that there's always a greatest common factor. That greatest common factor just might be 1. So let's go ahead and look at some problems and just identify the factors and the greatest common factors before we move into the next step of this. All right, so the first number that I'm going to look at here is 12. I'm going to identify all of the factors of 12. And I like to go in order. Does 12 divide by 1? Yes. 2, yes. 3, yes. 4, yes. 5, no. 6, 7, 8, 9, 10, 11, 12. And I'm done. And then I'm going to identify all of the factors of 32. 1, 2, not 3, 4, not 5, not 6, not 7, 8. Not 9, not 10, not 11, not 12, 16 is going to be the next one, and then 32. You can also notice that if you multiply, that's how it's kind of a good way to check that you're done. The two terms in the middle should multiply to give you that product as well. So I have all of these factors listed out. Let's go ahead and identify, and I'm going to do this highlighting in red, the common factors. Well, they both have a 1, they both have a 2, they both have a 4, and that looks like all of the things that they share on their list. So the common factors 1, 2, and 4. What is the greatest common factor? The greatest of those is going to be 4. So the greatest common factor is 4. Why don't you go ahead and pause the video and list out the factors of 8 and 24. See if you can identify the common factors and the greatest common factor. So here I have listed out the factors. I'm identifying the common factors. And then I'm going to go ahead and identify the greatest common factors. So common factors 1, 2, 4, and 8. Those are all common factors of 8 and 24. And the greatest of those, the greatest common factor, is going to be 8. Now, if you look at number 3, now I'm really trying to trick you. Now I'm throwing some variables in there. But let's look at 5 is really just 1 by 5. There's x squared means I have x times x. And y means that I have y. And if I look at 10, 10 is 1, 2, 5, and 10 are my common factors. It has 1x and 2 y's. So common factors, again, we can identify. They both are divisible by 1. They're both divisible by 5. They're both divisible by an x. They're both evenly divisible by a y. When we identify that greatest common factor, number-wise, that's just going to be 5. And then let's see what they have in common for variables. They have an x and they have a y. So our greatest common factor is going to be 5xy. So variables, you're really just counting how many they have in common. And we're going to go ahead and use this 5xy down here when we're talking about factoring out the greatest common factor. So let's go ahead and look at this next part. Let's add a step onto what we just built. So we just showed that the greatest common factor of 5x squared y and 10xy squared is 5xy. We just showed that that is our greatest common factor. And we showed that on this last example up here. When we factor something out, this is a new vocabulary. When we factor something out, we are basically, and this is not a real word, we are undistributing. And what I mean by undistributing is, as I know you all know very well, when we distribute, we're multiplying to get rid of parentheses. When we factor, we are creating parentheses to undistribute. We're almost doing the opposite of what we have trained you for so long to do, the opposite way. So what I mean by that here is, if 5xy is that common factor, what I want to do is to take that out, to divide each term by that and leave what's left over on the inside. So I want you to think about it as if I'm actually dividing each of these terms by 5xy. And what's left over when I do that? So let's look at this term first. Well, the 5's are going to divide out, the y's are going to divide out, and one of the x's is. So I'm just left with x. Plus, what happens when I divide here? 10xy squared divided by 5xy. Well, 10 divided by 5 is 2. X over x is nothing. It's just 1. Sorry, x over x is not nothing. X divided by x is 1. Y squared divided by y is y. So this gives me an expression now, a product of the greatest common factor times what didn't factor out or what they did not have in common. And something that's really interesting and kind of nice, I always like to be able to check my answer, is that since we're saying that these two things are equal, we can actually check that we did this correctly simply by distributing. If I multiplied here, if I multiplied 5xy times x, I would get 5x squared y, and that's what I'm supposed to get. If I multiplied 5xy by 2y, I would get 10xy squared, which is what I'm supposed to get. So that's one of the things I love about these problems, is that we can check to actually make sure that we're doing the math correctly. So if you're feeling like this sort of sounds familiar or this feels like something you may have done before, you probably have, but just in case, let's do some more practice problems to really make sure that we are feeling like we understand how to factor out the greatest common factor. So I'm going to walk you through number 4, and then hopefully we can work on 5, 6, and 7 together. So when I look at number 4, I notice, first, I want to ask myself, how many terms are there? Well, there are 3 terms, right? The terms are being separated by those plus signs. So I'm asking myself, with each of those 3 terms, what is the greatest common factor? And you're more than welcome to list out each term, 2x squared, 4x, which is 2 times 2x, 8, 2 times 2 times 2x. You're more than welcome to list out the factors in this way, but I think that by now many of you are feeling pretty comfortable just looking at those numbers and identifying what that greatest common factor is. And if not, feel free to do a little bit of extra work and make sure that you are understanding that, or just swing by student support. So, greatest common factor here. They are all divisible by 2. That's the largest number that goes into all of them. They do not all have an x, so all that they have in common is this 2, which means the 2 is going to go in front of the parentheses since I'm undistributing. That's what's going to go in front. What's going inside is what I get if I factored out, meaning I divided each of these terms by 2. So if I divided 2x squared by 2, what would be left over? Just my x squared. If I divided 4x by 2, what would be left over? 2x. And if I divided 8 by 2, what would be left over? Just plus 4. And I could check, so this is my answer, is this factored out undistributed expression here. I could multiply back out to check and make sure that I'm right. 2x squared plus 4x plus 8, so we are in fact correct. Why don't you go ahead and pause the video and identify the greatest common factor for number 5. Okay, number 5, the greatest common factor. So looking at the numbers 6 and 14, the biggest number that they're both divisible by is 2. Looking at the variables, the first term has an a and the second term doesn't, so no a's. They both have a b and they both have at least one c. So the first term has 3 and the second term has 1, so what do they have in common? They have just one c in common. So 2bc, that's my greatest common factor. That's what's going to come out in front of the parentheses that I'm creating. And what's going to go inside the parentheses that I'm creating is what I get when I actually divide out 2bc from each term. So 6 divided by 2 is 3. There's an a that's not dividing out. The b's are dividing out. And one of the c's divides out, which gives me c squared. When I look at negative 14, so this is going to be a minus, 14 divided by 2 is 7, and both the b and the c are going to divide out. So my factored expression is 2bc times the quantity, or the parentheses, 3ac squared minus 7. And we can check. This would give me 6abc to the third. This would give me negative 14bc. That looks like the original problem that we had, so we are very happy that we know we got this correctly factored. Number 6, the greatest common factor, 4, 6, and 15. Number-wise, the only number they all have in common is 1, right? There's nothing else that goes into 4, 6, and 15. So the greatest common factor number-wise is 1. They don't all have an x, but they do all have a y. So the greatest common factor here is just going to be y. That's the only thing that's going to go in front of the parentheses that I'm creating. And when I divide that y out of each term, that's going to give me 4xy plus 6x plus 15y squared. And again, I could distribute to multiply that out to make sure that I did get back to the place that I started, because factoring and multiplying are just inverse operations. Why don't you go ahead and pause the video and work on number 7 on your own. And before you get too far in, something that I should have messaged before, or said before I asked you to do this on your own, is that anytime this first term is negative, we really want to factor that negative part out as well. So now that I have mentioned that, go ahead and pause the video and work through this. So that's going to give us greatest common factor negative 3ab times the quantity a plus 2. And notice that negative changed to a plus because we factored the negative sign out. And if we distributed this back out, we would get, let me box my answer here, we would get negative 3a squared b minus 6ab, which is what we started with. Let's go ahead and challenge ourselves with this last question. Why don't you go ahead and pause the video and read the problem to yourself and see if you can figure it out on your own, and then unpause the video and see how I work through it with you. Okay, Number 8, the area of a court for the game of squash is 9x squared plus 6x square meters. And remember that the area is just the base times the height, or the length times the width. Factor this polynomial to find possible expressions for the dimensions of the squash court. So basically they're saying take the greatest common factor out so that you can have a base, actually let's color code this, a base times a height. Okay, so we are looking at 9x squared plus 6x. The very first thing I want to do, just like I did on every problem above, is identify that greatest common factor. Well, 9 and 6 are both divisible by 3, and it looks like they both have an x. So it looks like I'm going to identify my base, or one of the dimensions, as 3x. And then I'm going to take each term and divide it by 3x to find my height. So 9x squared divided by 3x is 3x. 6x divided by 3x is 2. So here I have my dimensions, except I don't want to forget my units. These are meters squared, because this expression, if I multiplied it, represents the area of the squash field. So each individual term is in meters, and if we multiplied them, we would get meters squared. So key parts of this lesson today: identifying not only the factors of different terms, but the greatest common factor, so that we can factor that greatest common factor out. And when we're factoring that greatest common factor, what we're really doing is we're undistributing, meaning that we're creating parentheses that we could multiply back out to check our answer. But our solution here, our answer to these questions when we're factoring out the greatest common factor, is the product that is equivalent if I multiplied it out. That can apply to area problems, that can apply to just numeric problems, but this is leading into a bigger idea of how do we factor beyond just identifying that greatest common factor. So make sure to write down any questions that you have, and I look forward to supporting you on this in class. Thanks for listening.